Hello and welcome to KISS Principles of Chemistry. Today we're going to be talking about limiting reactants. So I have our mole island map up here to help us go from mass to mole to mole to mass. And we've done this when we have been given the mass of one reactant and we want to find out the mass of a product. But how do we find out how much product we can make if we're given both masses of the reactants and we don't know which one we're going to run out of first? So let me give you an example of where you could see this happening in the real world. So I've got a box of carrot cake here. And let's say that I have 120 students and I want to make cupcakes for every single one of them. If I look at the back, this is like my mole ratio. So if I look over here for my ingredients, it says that I need 3 eggs and I need water and oil. So let's say I went to the store and I got 5 of these boxes and each box says it can make 24 cupcakes. So perfect. This will make my 120 cupcakes. I get home and I find out that I have a dozen eggs. So the recipe on here again calls for 3 eggs per box. So I've got 5 boxes. That means that I need to have 15 eggs. But when I look at my fridge, I only have 12. So because of that, I cannot make all 5 boxes because I am limited on the number of eggs that I can make. So instead, I'll run out of eggs before I run out of boxes. So this example, eggs are going to be my limiting reactant. It's one of my ingredients I'm going to run out of to make my 120 cupcakes. So how many cupcakes could I make then? Well, if each recipe calls for 3 eggs and I have extra boxes and each box can make 24, then that means that I can make 24 times 4 because I can make 4 boxes with my 3 eggs. So I can only make 96 cupcakes. So that's the max amount of cupcakes I make based on what I have. So now let's take this example and use it in an actual chemistry example. For our example here, let's say that we have on hand 30 grams of C3H8 and we have 30 grams of oxygen available. And we want to make water as our product. We want to know how much water can we make given 30 grams of reactant A and 30 grams of reactant B. Some people may say you could just take 30 plus 30 and then you get your total product. But we haven't determined if we're going to run out of one product before the other. So we have to use stoichiometry and we have to go from mass to mole to mole to mass of each substance to our product that we're wanting to determine. So for this starting out here, we're going to go ahead and do 30 grams of C5H8 over 1. Since we're going from grams to moles to grams, we're going to need 4 division bars to be able to complete this process. So now we need to figure out how much of this are we going to be able to have. So we start out with the molar mass of our first one because we need to do 1 mole is equal to how many grams of C5H8. And this top is also C5H8. So we're wanting to figure that out. We also need to convert to moles of our product that we're desiring. So we're going to put mole of H2O on top, and then we're going to go to grams of H2O. So grams of H2O is our final numerator. Now we're going to go through the bottom and cancel out all of the units that we no longer want from the top. So we've got grams of C5H8. We also are going to have mole of C5H8 and mole of H2O on bottom. Now I can go in and fill in the numbers. So the mass of 1 mole of water is equal to 18.02 and the mass of C5H8 is equal to 68.13. These numbers come from the periodic table. Next, I need my mole to mole ratio of water to C5H8. So in this case, I have 1 mole of C5H8 to every 4 moles of water. So I can multiply across the top, find our product, and then divide by our denominator product, which is 68.13. Once I have done the multiplication of the numerator and divided by the product of the denominator, I find out that I can make 31.74 grams of water from 30 grams of C5H8. Now I need to do the same for our second reactant, which is oxygen. We have 30 grams of oxygen, and we need to convert that into grams of water also. So again, going across the top, converting based on what we have. So we know we can go from grams of oxygen to mole of oxygen, and then we can go to mole of H2O, and then we can go to grams of H2O. Now on our denominator, we're going to use the units that we want to cancel out. So I want to cancel out grams of oxygen, mole of oxygen, and mole of H2O. Now I need to fill in the numbers. So in this case, 1 mole of oxygen is equal to 32.00 grams of oxygen. Our hydrogen in our balanced equation, our water in our balanced equation is 4 moles to every 5 moles of oxygen. We get both of those numbers from the balanced equation. And 1 mole of water is equal to 18.02 grams of water. So now I will go ahead and multiply and get our product for the numerator, find our product in the denominator, and divide by both of those to get our mass. All right, now that I have solved my bottom, I can make 13.5 grams of H2O. When I look at both of these numbers, if I want to know how much water can be made, I have to look at which mass is smaller. So this number here, 13.5, is smaller because that means that we have run out of oxygen before we have run out of C5H8. So this is what we call the reactant that is limiting. So limiting reactant is oxygen. And then the one that makes too much is what we call the excess reactant. So that means that we have more C5H8 than what we need to pair up with oxygen to make our final product. So the maximum amount of product that we can make based on 30 grams of C5H8 and 30 grams of H2O is the smaller mass. In this case, that is 13.5.